Okay, welcome. We're going to try creating some notes for AP Stats and see how that goes. Today we're going to be covering the 5-number summary, determining outliers, and creating box plots. So there are blank notes on the site, but I'm going to go through these and just summarize for you. Let's zoom in a little bit here. Okay, so if we want to do a 5-number summary, the first thing we've got to do is put all our points in order from smallest to largest. First thing you're going to do is find the median. And again, the median is the centermost point. If you have an even number of points, it'll fall between 2 points. So in this case, there was 12 data points, so between the 6th and 7th point. Take the average of those two, and we get the median. To find Q1 and Q3, we take the bottom half and find the median of the bottom half, in essence. So there's 6 data points here. So between the 3rd and 4th data point, which they're the same, so that is the median in the bottom. That's called Q1 or quartile 1. Likewise, we do the same in the top half of our data. Halfway between the points is Q3. Take the average since there's an even number of points, and we get Q3. And what these numbers represent, Q1 is quartile 1. So quartile hopefully makes you think of 25%. So 25% of the points are below this value, 75% are above it. For our median, 50% of the points are below it, 50% are above. And finally, for quartile 3, 75% of the points are below that value and 25% are above it. The other two numbers that go into our 5-number summary are the minimum and the maximum. So those 5 items make up your 5-number summary: the minimum, Q1, median, Q3, and maximum. And we need to have done those before we can calculate mathematically our outliers. And outliers are unusually high or low data values. And we actually have a formula for that. To find the upper limit for outliers, you take your Q3 value plus, I'm going to put parentheses here, 1.5 times the IQR value. And I don't have that on here, but let's just write down how we find IQR, which stands for interquartile range. And that you find by Q3 minus Q1. So in this case, 41 minus 34 are 7, in other words. So the upper limit for our outliers is Q3, which was 41, plus 1.5 times the IQR of 7. The lower limit we find by taking Q1 minus 1.5 times the IQR. And again, I would put parentheses around that, just mathematically, that looks better to me. Okay, and the actual values here, 41 plus 1.5 times 7 gives us 51.5. So anything above 51.5 is a high outlier. Anything below 34 minus 1.5 times 7 gives you 23.5, would be a low outlier. And notice that we don't have any low outliers here. It asks, do we have any outliers? We have 2 high outliers, and those were at 67 and 185, because they both are higher than our upper limit here. Okay, we have a box plot drawn in here. And let me talk about what makes up a box plot. The first thing you would do is you would draw in your scale. So for this one, your median value is here. The solid line to the left is your Q1 value. The solid line to the right of the median is your Q3 value. And you draw basically a rectangle there. You then draw a straight line for your minimum value, provided it is not an outlier. So the smallest data point that is not an outlier, you draw a line at. And you connect it to the rectangle with a line, in a horizontal line. You do the same thing for the maximum value, for the largest value you have that is not an outlier. So you draw that in. And then any outliers, both high and low, you draw as dots. Let's turn to the next page. Okay, and looking at the top of the second page. So this represents a right skew. Notice how the right side of this rectangle is bigger than the left, and this whisker is much longer on the right side than the left side. That tells us it is a right skew. So if you looked at this one, it's longer on the left side. You would be correct if you said that is a left skew. Okay, here's one using our actual data points. So our minimum value is 29, so I draw my straight line for the minimum there. Notice there's no outliers, so I don't have to worry about putting dots on the left. My Q1 value, median, Q3, I drew my straight line for the maximum at 43 because that was the largest value that was not an outlier. And I continued then and I drew the 2 points for my outliers. Notice this is not to scale whatsoever. That would not be acceptable for a box plot. We do want them to scale, and I'll show you what this would look like. Before we get to that, what percentage of the data is below below Q1? So that's 25%. What percent is above Q1? Well, if there's 25% below, there must be 75% of our data above it. What percent of the data is below Q3? So Q3, remember, was here. We have 75% of the data below it, and 25% is above that. Oh, sorry, above the median. I should read the full question. Above the median, we have 50%. And what percent of the data is within the IQR? Well, remember, the IQR is Q1 to Q3. So if this is 25%, this is 25%, this is 25, and this is 25, between these two must be 50% of the data. Okay? So now we've got a box plot drawn on its side, and that's okay to do. You will see them this way occasionally, especially if you're being asked to compare distributions with box plots. They sometimes will put them side by side. So this one is to scale, notice. So here are the values for the salaries. There is my largest outlier, probably our CEO of this company, maybe the manager, and then most of the employees are grouped right in here. And if we want to describe the distribution, remember the letters I use for context, I would say be specific or BS, and I would use CUSS as our letter, so CUSS. Again, some teachers use the SOCS. Whichever one helps you remember it is perfectly okay to use. Okay, so for the shape, we could talk about a skew, but we cannot talk about how many modes or how many peaks it has because we don't know in a box plot. So when you're asked to describe the distribution with a box plot, talk about the skew. And if we were to look at the skew on this one, well, let me just take a quick look here. We would have to turn it so the smallest number is on the left, the largest is on the right. So looking at this, our skew, we've got these outliers over here. Your skew is generally towards the outliers. So it's going to be skewed to the right. We could talk about outliers, and on a dot or on a box plot, they're going to look like dots that are out there. The center is going to be your median. And the spread, when you've got a box plot, you want to use the IQR. And sorry, I just didn't think I could write that neatly in the box there, or in that line. So IQR is what we use to describe the spread. Okay, so the data was collected on salaries here. So that gives me my context. I'm being specific. The distribution appears to be right skewed because it was towards the higher number. And there are two high outliers, and we want to say exactly where they are. There was one at 67 and one at 85,000. I'm just going to put a K there. The blank of the distribution is 34,500, the median, that would be. And the interquartile range is 7,000. Okay, and let's go to the third page now and take a look. Okay, at the top of the third page, here we're going to compare two different tax plans, each with an average tax cut of $4,000. Well, notice how we've got the two box plots. Look at where the medians are. So we've got a median right here, and we've got a median here. So neither of these medians are at 4,000. The average of their data points may be 4,000. And if we want to compare dot plots, stem plots, histograms, box plots, we always want to use CUSS and then be specific. So center, unusual, shape, spread, and be specific. So that's your context. We need to use comparative language. Comparative. Anyone else have to sound out words sometimes to spell them? So these two things are good to keep in mind for free response questions. You will always need to use this. And I've never seen an AP Stats exam without a free response question asking for you to compare things. And keep in mind, comparative language is less than, greater than, anything that make sure you're comparing them, not just stating the numbers. And again, I don't really like using these, so I would be using a U for the O, so it's cuss, and I would use BS for context, but whatever works for you. So here, household tax cuts, and we're talking in dollars here, under Plan A are left skewed. So again, that's left, oops, you can't see me, left skewed because it's much longer on the left side compared to the right side of the median. Whereas on tax Plan B, that's obviously a right skewed. So severely right skewed under Plan B. There are no outliers under Plan A, but Plan B, there are several outliers. And I put that they're higher than 12,000 because that was the largest, or the cutoff there. The median tax cut under Plan A, which is about 4,750, is, so that is higher than the one under tax Plan B. And Plan A also has blank IQR. So the IQR, remember, is the distance from Q1 to Q3. So Plan A has a much larger IQR. So it has a higher or larger, whichever word you want to use, larger IQR than Plan B. So we are comparing those. Okay, and continuing down below, there's a discussion question. And we're going to try and bring in a lot more real world examples, or current examples. And here's a quote that said the average American family would get a $4,000 raise under President's tax cut plan. So how could any member of Congress be against it? And they were talking about this tax Plan B right here. So I want you to think about, why would this maybe not be the best tax plan? Or what is different between them? And use what we know about statistics. If we talk about the average tax cut for both of these was 4,000, look at Plan B. We're tightly clustered down here and then some spread up here. So these large values are what are pulling the average of this up. So remember, the average follows the outliers or the skew. Median is pretty fixed. Tax Plan A has a higher median, but much smaller down, or much more spread out here. So again, take a look at these and try and use the comparison of why one might be better than another. Okay, and let's look at the last page now. Okay, and this is page 4. So here were what some of the critics said about the tax plan, is that if you were low income, you got no tax cut. If you were middle income, you pretty much got no tax cut. But if you were high income, you got a large tax cut. So that gave us a large average tax cut. Seems great. But averages follow skew and outliers. So this is sometimes called the flaw of averages. So we don't always want to talk about averages because that can distort what is really going on for the majority of our data. Critics of the tax plan argue that once we got reliable data, the Trump tax cut looks more like Plan B than Plan A. The median tax cut would be much lower than 4,000, with tax cuts well below 1,000 for the majority of households. Again, looking at the IQR to get that. This is why we describe the whole distribution of data versus just a single number such as an average. Because looking at the whole set, a whole group of data, we get a much more complete picture of what's going on. And so that means looking at the 5-number summary or looking at the full graph of the data. Okay, so go ahead and get started on the homework. This should be from section 1.3 in the textbook.